Good morning, dear students. Myself, Dr. Lingaraju, Government Fashion College, Tumkur University. So, in the physics subject, the paper of semiconductor device, digital electronics, laser, and also fiber optics. Today, we'll discuss some problems in numerical aperture, optical fiber, and also in the attenuations. So, what last class we observed in the optical fiber is we are going to discussion about a optical fiber and how the light propagation will takes place in the optical fiber. What is the meaning of total reflections? All these things last class we discussed. So today we are going to understand how to develop the problems in the solving skills in a numerical aperture or attenuation concepts. After knowing the discussion of this concept, so we are going to develop the solving of problems. So here let us begin with the first problem. So first find the intensities of a laser beam of 20 milliwatt power and having a diameter of 1.3 millimeter. Assume the velocity to be uniform across the beam. So here they are given laser beam power is given, that is 20 milliwatt, and also they are given the diameter of the optical laser beam. Assume the intensity uniform across the beam. So that is intensity here we are going to calculate. I is equal to P by A. A means area of cross section, that is pi r square. So knowing this concept, so R means radius. So we will write it through the diameter because they are given the diameter. They are not given directly the radius. So using the diameter we can calculate the radius. So that means 4p by pi d square. Substitute the values. 4 into p. What is the value of given 20 milliwatt into pi into d. Diameter is given 1.3 10 to the power minus 3 whole square. After the calculating of all these things, we are getting 1.5 so kilowatt per meter squares. So this is the way here we are going to calculate the first problems. So next is in a helium neon laser, the two plane mirror forming the resonant cavity are at a distance of 0.5 meter. What is mode separation of longitudinal cavity in terms of frequencies? So it is a very good problem. You see here they are given the distance, that is L is equal to 0.5 meter, and also knowing this one we have to calculate the frequencies, that is delta nu. So consecutive modes delta nu is equal to c by 2 lambda 2l, sorry. C means velocity of light, 3 to the power of 8 divided by 2 into 0.5. It gives the 3 into 10 to the power of plus 8 hertz. Very simple problems. Third one is a laser beam can be focused on a area equal to the square of its wavelength. If the laser radiates energy at the rate of 2.5 milliwatt, calculate the intensity of focused beam. Here they are given one value, that is lambda 6328 angstrom for a helium neon laser. So intensity I is equal to P by A. So that is equal to 2.5 into the power of minus 3 by 40 into the power of minus 14. So calculating of all this power and also the area. So here we are getting the answer is 62.5 into the power of 8 watts per meter squares. That is the way here we are going to calculate the intensities. Next problem, fourth one. Find the ratio of population of two energy levels out of which one corresponding to metastable state, if the wavelength of light emitted at 330 Kelvin, if the wavelength 632.8 nanometer. So here they are given the metastable state in the two energy levels. So ratios, that is N2 by N1. N2 is metastable state level, N1 is ground state number of electrons. That is equal to e to the power of minus delta E by lambda kT. So here they are given all these given values. Delta E. Delta E value is not given. We have to make it simplify this equation. Delta is equal to Hc by lambda. So instead of delta I, we can say Hc. H minus of 6.63 into 10 power minus 34 into 3 into 10 power 5 divided by 6.328, that is the wavelength, into K, Stephen Boltzmann's relation value. 1.38 into 10 power minus 23 into 330 Kelvin. Calculating of all these values, here we are getting 1.059 into 10 power minus 30. Next is fifth problem. Find the number of modes of the standing waves and their frequency separation in the resonant cavity of length 1 meter of helium neon laser operating at wavelength 632.8 nanometer. So it is very simple and interesting problem. Here they are given difference between the frequency of a consecutive mode, that is delta nu is equal to C by 2L. So calculate that value is 3 into the power of 8 velocity J by 2 into L. L value is 1 meter. That is equal to 1.5 into the power of 8 hertz. Distance between the mirrors, L is equal to n lambda by 2 or n is equal to 2L by lambda. That is equal to 2 into L 1 by 632 into the power of 8 10 to the power of minus 9. Value of this one, it gives the distance between the mirrors. That is equal to 3 into 10 to the power of 3.16 into the power of plus 15. So after knowing this, we have to calculate the number of modes on standing waves. So number of modes of a standing waves, n is equal to, so n is equal to 3.16 into the power of plus 5. So like that, here we are going to calculate how many number of modes standing waves are there in the frequency separation of resonant cavity. So it is also very easy. So like that, here we are going to solve so many different type of problems using a Einstein's coefficient relation, and also a modes of proportion relations, and also attenuation problem relations, and also energy difference between two energy levels using the relations. So all these things here we are going to calculate so many different type of problems. So in this chapter, what here we are going to solve the problems all are very small simple problems and also very simple formulas. It is easy to achieve very good marks also, because in the final year BSc degree, so they are asking each problem for 5 marks. It takes only 3 to 4 steps. If you know the basic concepts behind the particular subject means, so you can easily understand and also you can easily attempt the particular problems. So please, always you should be understand all the problems, whatever the problems is. First you should understand the given problems. After knowing the problems, write the given datas, whatever the things are given. After knowing all the datas, we can easily guess it which formula is required to solve this problem. So with unit you have to represent, then only we can achieve a good result. And also all these problems in the laser chapter are a very simple formulas. Here it is not having any complicated relations. So far we can easily achieve, we can easily get it to solving of this type of problems. Thank you one and all.